first question is from March 2020, paper 32, question number 1. They say that there are 40 members of a club and they are going somewhere. 35 of them will travel in a coach and 5 will go in a car to a concert. Okay. Ranuf will be in coach and Said will be in car. So let's draw a coach. Suppose this is the coach and Ranuf is one of them. This is car and Said is one of them, right? Now they're saying in how many ways can the members who will travel in coach be chosen? Chosen means we'll use C, right? Combination. So out of how many we have to choose now? It is certain that Ranov is in coach and Said is in car. That means 38 people are left. From those 38 people, we have to choose remaining 34 because Ranov is already here. So we need more 34 more people because total 35 people can come in the coach. So we will choose 34. And that's what it will be, 73,815. That's straightforward. 3 marks for this. This is question 4 of March 2020, paper 52 again. Here they say that Richard has 3 blue candles, 2 red and 6 green. All candles are identical apart from their colors. That means you can't differentiate between 2 green or 2 red or 2 blue candles. Why they say this sentence? It means that even if the candles interchange their places, they will look similar. So we don't have to take care of that. All right. Find, A part says, find the number of different arrangements of 11 candles if there is a red candle at each end. So red here, total there are 11. That means there are 9 in between, right? So we don't have to bother about red anymore. They are fixed, right? So these 9 are the ones who are to be arranged. So if there are 9 places and 9 candles, they will be done in 9p9 or 9 factorial. Straight away write 9 factorial. But 6 green candles are similar, so we'll divide it by 6 factorial, and 3 blue are similar, so we'll divide by 3 factorial also. So whatever number that gives, we will not change R and R with each other also. So let's see what our calculator gave. And it comes out to be 84 arrangements. Let's move on to the B part. Find the number of different arrangements of 11 candles if all the blue candles are together and all red candles are not together. All right. So that means we have to move blues together. How many blues are there? 4 of them, right? 3 blues are there. So let's write them together, and in a box they will move together. They are bound. Okay. Now we want the red ones, they not to be together, right? Red candles are not together. That means 6 greens will be somewhere here. Green, 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 green. 1, 2, 3, 4, 5 and 6. All right. Now we will treat blues as one entity. So there will be how many? 1, 2, 3, 4, 5, 6 greens and 1 blue. There will be 7 places now, and we can arrange them in 7 factorial ways, right? Blues, we don't want to count them as 3 factorial or anything else because they are similar, so no need to do that. But these G's, there are 6 of them same, so we'll divide them because we have not considered them to be 1, right? So 7 factorial divided by 6 factorial will be the arrangement of these. Now the reds should not be together. That means red can take these circles. I'm drawing circles. 1, 2, 3, 4, 5, 6, 7 and 8. These are the 8 places available for reds, but they are not 8. They are how many? They are just 2. So they will take 2 places anywhere of any of these 8 circles they will take, and they will be not together. But both of them are similar, so we have to divide by 2 factorial because 8p2 will arrange them a certain way. But if they interchange their places, that will also be counted here. That we have to remove by dividing by 2 factorial. So this should be the answer, and let me put this in my calculator. Let's see how it goes. And the final answer for this came out to be 196 when I used my calculator. This one is question number 2 from summer 2020, paper 51. Here they say that there is a word jewelry which has 9 letters, and we want find the number of different arrangements that can be made in which E's are together and L's are together. Whenever they say that certain letters are together, write them together and make a box around them. That means they are not 3 letters anymore, they become 1. Wherever they move together. Now 2 L's are also together, so we'll bind the 2 L's, right? But these E's and these L's can move about independently. Okay, so now we are left with J, W, R and Y, right? So now there are 6 places, 1 place for E's, 1 place for L's, and 4 places for others. There are total 6 individual entities, and we have 6 places for them to be kept. So when we have 6 and we have to put them at 6 places, it becomes 6p6, which is equal to 6 factorial, and if I evaluate with my calculator, it gives me 720 arrangements. There's no need to further multiply by 3 factorial. When these are same, there is no need. If they were different, then we would further multiply 6 factorial by something, but in this case, it is not needed. That was A part. Let's talk about the B part. Same, the word jewelry, and they are asking for the number of different arrangements that can be made in which 2 L's are not next to each other. So whenever they say that certain number of alphabets or people or something are not together, exclude them. So out of 9, if we remove those 2's, we get 7. So we'll draw 7 places. 1, 2, 3, 4, 5, 6, 7. We'll just see how these 7 can be arranged first. So 7 places, 7 alphabets, 7 factorial, right? But since E's are exactly identical, they will not change the arrangement. We have to divide it by 3 factorial. Now let's talk about the L's which are not to be together. So we will draw some circles in between these where these L's can take place so that they are never next to each other. So there are 7 alphabets, we have 8 spaces around them. If you count these circles, there are 8. So out of these 8, those L will choose any 2. So we can write 8C2, right? And just evaluate it. Or else we could have done this 7 factorial over 3 factorial and 8p2 and then divided by 2 factorial. Why? Because else if they suppose one L took this place and one L took this place, so if they interchange their places, still the arrangement will be same. So this 2 factorial will remove those cases, just like the previous example in this video. And if you don't want to divide by 2 factorial, just write in place of p, write c, that arrangement, the order is not important. Both of them will give you the same answer, and I think it will be, let me see, 23,520. This one is again summer 2020, paper 51, and it says that in a music competition there are 8 pianists, okay, 4 guitarists, 6 violinists. 7 of these musicians will be selected to go through the final. Okay, they are how many? 12 plus 6, 18. Total they are 18. We have to choose 7. All right. How many different selections of 7 finalists can be made if there must be at least 2 pianists? Okay, we want at least 2 pianists. That means we can have 3 pianists, 4 pianists, and so on. All right. At least one guitarist, okay, and more violinists than guitarist. Okay, so let's see this combination first. 2, 1, and it has to be more. So we can make it 2 plus 1 is 3, 3, and that means we need 4 violinists, which is possible. Alright. Second, let me again go to the 2. Let me remove these two first so that we don't confuse. Alright. So again, 2 pianists, but guitarists become 2. So 2 plus 2 is 4, and violinists are 3. They are more than guitarists again. Again 2. Yes, this becomes 3, and violinists have to be more than 3. That becomes 4, but we have to choose just 7, and they are 9. So that means this condition cannot be met. Let's go to 3. Again, at least one guitarist. So 3 plus 1 is 4, and 3 violinists are needed. Okay. Next, 3 pianists. This becomes 2. So 3 plus 2 is 5. 5 plus 2 is 7. That means this case is also failing. Let's say 4 pianists, 1 guitarist, and 2 violinists. 4 plus 1, 5 plus 2, 7. And 4 plus 2 will be 6, and that will not make, and 5, and that will not leave anything else. So these are the only 4 combinations possible, and we will write the choice selection process for these. Okay, so there are 8 pianists in this line. Okay, 8 pianists, we are choosing 2 out of them, and 4 guitarists, we are choosing 1 of them, and 6 violinists, we are choosing 4 of them. Similarly, and now we have listed them. Just put them in calculator, put a plus in between every selection, because only one of them will happen, not all of them. They are mutually exclusive cases. So we'll just add them and write our answer. And if I use my calculator, I got 13,720 combinations possible. This is question number 6 of summer 2020 paper 52, where they have given this word, summertime. So they are total 10 letters. That's what they have told here. They can be arranged when it starts with E and ends with E. So let's write E here, and let's write E here. So ends are filled with E's. How many are left in between? 8, right? And those 8 will interchange their places because there is no other E. So it will be 8 factorial. But something is repeating that we have to take care of. U is not repeating, M is repeating 3 times. So we have to factorial 3. All right. And R is not, T is not, I, nothing else is repeating. So this will give us the answer, which is 6,720. B part. Find the number of different ways in which 10 letters of summertime can be arranged so that E's are not together. So since E's are not to be together, we'll look at the rest of the 8. 1, 2, 3, 4, 5, 6, 7, 8, right? And they can be arranged in 8 factorial. And again, M is coming out to be 3 times in those, which is 6720 again, right? But we have to take care that E's are not together, and E's will take up these 9 places. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now you might have noticed similar kinds of questions are repeating. So 9 places are there, and we have to give those places to 2 E's. We don't have to divide by 2 factorial if there is C here. If it was P, then we would divide. Just multiply this and you'll get the answer for that as well. It's 241,920. Okay, let's go to C part. 4 letters are selected from 10 letters. Okay, Find the number of different selections if the 4 letters include at least one M, okay, one M, and exactly one E. All right. So what are the possibilities? So we'll write M, E, and others, right? So at least one M means let's start with one. And they said exactly one E, one, and we need to select 4. The remaining others are 2, right? Next, at least M also includes 2 M's. So 2 M's, one this, and remaining is this. 2, this will be 3 now. Do we have 3 M's? No, we have 3 M's, yes. 3 M's and 1 E and none of others. And there is no other possibility. These are the only 3 possibilities. So now we will interpret them into selection. Selection means combination we'll use. We have to select 1 M out of 3. So normally it would be 3C1. But since all the M's are same, we don't know which M we chose. So there is no need to bother about what we chose. Just write 1. Whenever the number of choices are same, identical, we will write 3C1 and further divide by 3. So we don't know because we don't know which one was counted. So that's why we don't need to bother about it. So just write 1 selection, any 1M. Similarly, E is exactly 1 out of the 2. So we have just one E, we don't know which one we selected. But what creates problem is the others. So there are total, how many? 10 letters. 3 M's are gone. 2 E's are gone, so 5 are gone, so we are left with 5. Out of those 5, we have to select remaining 2, right? Because 1 is M, 1 is E, and we have to select 2 from the rest of them so that they total become 4. 4 letters are to be selected. Now, second one, it will again be 1, 1, and 5C1 we need because selection of M is definite. Selection of E is also sure, but which of the other remaining 5 is chosen, we don't know. I hope no one else is repeating. Yeah. So let's go to third one. 1, 1, and here out of 5, we have to select none. Why? Because 3 plus 1, 4 are already selected. We don't need any. So just add these 3 and we will get our answer. What I got was 16. This is question number 7 from summer 2020 paper 53. A part says find the number of different possible arrangements of the 9 letters in word celestial can be written as. So there are 9 of them, so 9 factorial ways. However, E is repeating twice. Can you see? So we will take care of that by dividing by 2 factorial. And L is also twice. And there is no other one which is repeating. So this is the number of different possible arrangements, which came out to be 90,720 arrangements. Let's go to the B part. The B part says find the number of different ways of celestial in which first letter is C, okay, the fifth letter is T, 2, 3, 4, 5. Fifth letter is T, and the last letter is E, 6, 7, 8, 9. Alright, so first letter is C fixed and C is alone, so we don't have to worry about C now. C is out of the contention. T is not repeating again, so T is also gone. So we are happy with these two, they are fixed at these places. E is repeating twice and one of them is here. But we are not sure which one is here because E and E both are exactly same. So one will be fixed here, which one is not important. The other one will be among the other 6 and it will be alone. So again, we don't have to worry about any of these 3. Just worry about these 6 places. These 6 places will be arranged in 6 factorial ways, and L is the only one repeating now. E is not repeating because E is 1 in these 6 places. and this is the answer. If I put this in my calculator, I get 360 arrangements. Now the C part. Okay, C part says find the probability that a randomly chosen arrangement of the 9 letters in the word celestial does not have two E's together. Again, the repetition of what examples we have solved in this video. So, two E's should not be together. That means we will keep them out of it, and rest of the 7 we will write 1, 2, 3, 4, 5, 6, 7. Let's worry about these 7 first, remaining ones. So, it will be 7 factorial ways they can be arranged. Divide by what is repeating? L is repeating. So, divide by 2. Now, we will choose the gaps between these 7 because the E's must not be together. That means there should be someone between them, and out of these 8 places now, these circles are 8. Out of 8 circles, we have to choose any 2 places where we can keep E's. It will give us 75, 60. But if you take notice, they ask us the probability. So we have to divide it by total number of possibilities. So a probability that E's aren't together will be 7560 divided by total. Total we got in A part. Let's see how much is that. 9720. Which came out to be 7/9. Alright, there is a D part also. Let's go to the D part. 5 letters are selected randomly from 9 letters of celestial. Find the number of different selections if 5 letters include at least one E. Alright, so just like previous example, at least one E. Alright, so it can be 1 and more. And at most one L. That means we can have 0 else also. So let's start with 0. Okay, so 0 else and 1 else are possible. At most 1 means this. So we'll go to, let's start with at least 1 E. Alright, so we'll write others. Others are how many? There are 2 E's and 2 L's, so 4 of them are out, others are 5. Okay, so we have to select from those 5. Okay, so 1 E and 0 L. So how many we have to select? 5 letters have to be selected. So 4. So 1 plus 4, 5. Alright. 1, 3 and 1. That is also 5 because at most 1 L we need. Let's go to 2 here and then we need 0 here. So 2 plus 0 is 2 plus 3. 2 here, 1 here. So we can have 2. Okay, so next is 3. It will be 0 here. But okay, E's are only 2. We can't have 3 E's. So we have to stop here. So these are the only 4 possibilities. Let's interpret them with arrangements. We need one of the 2 E's, right? But both of them are same. We are not sure which one are we selecting. So there is no selection in this. One means there is only one case that E is taken because both are identical. If they were different, then we would see something. Similarly, L is not taken. So 1 for that. So middle selection is the only thing remaining with us, which will be 5C4. Out of 5, we are selecting 4. And none of them is repeating, so we don't have to worry about that. Right? Number 2. Again, we are selecting 1. Which one is not important. We are selecting 1 L. Which L? No issues in that. And here we write 5C3. This one. Both the E's are selected. And there's no doubt that both of them are E's. So no doubt here. Again, 1 here. 5C3. This one. 1, 1 and 5C2. Right. Just add, basically everything else is 1, so we can add the middle ones. Just add these and you'll get your answer. When I used my calculator, I got 35 arrangement for part D. This question is from November 2020 winter, paper 51, question number 7. Here they say find the different number of different ways in which 10 letters of word shopkeeper can be arranged so that all E's are together. So there are 3 E's only, 1, 2, 3. There's no fourth E. So that's best. So put those E's together and make a box around them. Wherever they move together because they have to be together. What are left? There are 10, so 7 left. 1, 2, 3, 4, 5, 6, 7. So 7 of these and 1 E. It becomes 8 factorial arrangements. E is not repeating because we are making them 1. So there's no need to divide by 3 factorial. But something else might be repeating. P is repeating twice. SHORK. No. Nothing else is repeating. So this is 20,160. Okay, this was A part. Let's talk about the B. Find the number of different ways which the 10 letters of shopkeeper can be arranged so that P's are not next to each other. Again, exclude P's. Without P's, there are 2 P's, right? So without P's, there are 8 of them. So put 1, 2, 3, 4, 5, 6, 7, 8 and focus on these 8. These 8 will have an arrangement of 8 factorials and E's are repeating. There are 3 E's, right? So 8 factorial divided by 3 factorial. Now we'll talk about the P's. P's can take this place or this or this. These places, there will be 9 places. These are the gaps because every time something will be in between them. That's how they are not together. So out of these 9 gaps, you have to select any 2 to put P's on them and you'll get your answer, which comes out to be 241,920 arrangements. Question 6 of winter 2020 paper 52. Mr. and Mrs. Ahmad with 2 children and Mr. and Mrs. Baker with 3 children are visiting activity center together. They will divide into groups for some activities. In how many ways can 9 people be divided into a group of 6 and a group of 3? So we can select 6 people first. So total we have 9 people. We have to select 6, right? Which is selected first, who is selected first, second, third is not important. So that's why C here. Now remaining are 3 people and we have to select all 3. And this is what it will give us the answer. Similarly, we could have selected 3 people first, 9C3 first and then 6C6 second. Both of these will give you the same answer, which is 84 arrangements. All right. 5 of the 9 people are selected at random for a particular activity. Okay. Find the probability that this group of 5 people contains all 3 of the Baker children, and that's it. Okay, that is the B part. So 5 people are selected. So 3 of the Baker children, they are there. So we don't have to touch them anymore. Who is remaining now? There are, after 3 are selected, 6 are left, right? Out of these 6, we have to select any 2 people, right? And that will be our number of arrangement that Baker's children are there, number of arrangements. But they're saying probability. That means we have to divide this by total selection. Total selections are 5 out of 9. So if we divide it, we'll get our probability. This comes out to be 15 out of 126. So we can divide by 3, 4, 2. Okay, this is the probability, 5 out of 42. You can also convert it to decimals if you want. All right, C part. Find the number of different arrangements. Okay, sorry, all 9 people stand in a line before that, okay? Mr. Ahmad is not standing next to Mr. Baker. So remove the 2, Mr. Ahmad and Mr. Baker, and remaining people are 7 people. 1, 2, 3, 4, 5, 6, 7. And we know the gaps between those people where they can stand so that they are never together, okay? And we have how many gaps? 8 gaps. isn't it? So first we will talk about the people, 7 people who are standing. They can also change their places. So 7 factorial is the way those 7 people can stand. And then we have to give 2 places to Mr. Ahmed and Mr. Baker. So it will be, places are how many? 8. If you count the number of circles, 1, 2, 3, 4, 5, 6, 7, 8. So 8 of them, and we have to select 2 places for Mr. Baker and Mr. Ahmed. Since they are different people, so we are using permutation here. We are not using combination. In previous examples in this video, we used C because we had same alphabet, identical thing, but Mr. Ahmed and Mr. Baker are different, so we have to use permutation here, and that will give us our answer. We got 282,240 ways they can stand up. Okay, there is a D part also. Let's talk about it. Find the number of different arrangements in which there is exactly one person between Mr. Ahmed and Mr. Baker. Okay, let's look at the picture we drew for the first part. Again, this time this will be the situation, but in previous situation, Mr. Ahmed could have stood here and Mr. Baker could have stood here, right? That was the opportunity. But now they're saying that Mr. Baker has to stand here if Mr. Ahmed is here. They will have exactly one person in between them. So first step, we have to see that the remaining 7 people, how many ways they can stand. And they can stand the same way, 7 factorial. Now let's talk about Mr. Ahmed and Mr. Baker. This is one arrangement they can be. So Mr. Ahmed is here, Mr. Baker is here, right? The second arrangement could be that Mr. Ahmed takes this place and Mr. Baker comes here, right? Or Mr. Baker comes here, right? But I will not take this one. I will just take one case right now. So first case was when Mr. Ahmed was here, Mr. Baker was here. Now, second one is Mr. Ahmed is here, Mr. Baker is here. Similarly, we'll keep on going one way here, and we'll say, you'll see that we'll get 7 ways. 1 way here, 2, 3, 4, 5, 6, and 7. Here Mr. Ahmed and here Mr. Baker. There are 7 arrangements possible. But we did not take into account the ones on the right side also. So first of all, let's write 7 of those. And Mr. Ahmed and Baker can interchange their places, isn't it? So the moment I said this, Mr. Ahmed is here and Mr. Baker is here, can't it be Mr. Baker is here and Mr. Ahmed is here? Still that requirement of having one person between is met. So every 7 cases, every case is multiplied by 2 because both the arrangements are possible, AB or BA. So 7 factorial is the arrangement of other people, and 14 ways these 2 guys can sit and stand, and we can multiply all of them and we'll get our answer, which is 7560. These many ways this can happen. This is question 3 of winter 2020 paper 53. In A part, they're saying there is a committee of 6 people is to be chosen from 9 women and 5 men. Find the number of ways in which 6 people can be chosen if there must be more women than men. So total we want 6. So let's write men and women. We want more women than men. So we can have 0 men, 6 women. 1 man, 5 women. 2 men, 4 women. 3 men, and we can't have 3 women. They can't be equal. So we have just 3 possibilities. So we have to select no men out of how many? 5 men. So it will be 5C0 multiplied by 9C6. Second will be 5C1 multiplied by 9C5. And 5C2 multiplied by 9C4. Just multiply them and add, we will get our answer. When I use my calculator, I got 1974. Alright, let's go to the B part. 9 women and 5 men include a sister and a brother. Find the number of ways in which the committee can be chosen if the sister and brother cannot both be in committee. This is a very repetitive question asked over the years. So, what can you have? We say either brother, not sister, right, in the committee, or sister is there, but brother is not there. And third option will be neither of them. These are the three possibilities, yes or no? They're saying if the sister and brother cannot be both on the committee. So there's also a possibility that none of them is in the committee. All right. So let's look at this one first. Brother is there in the committee is certain. So he is fixed. Okay. So now we have to select 6 of them, right? Yes, 6. So brother is already in and sister cannot be in. So 2 of them are out of the total people. Total of 9 plus 5, 14. The 14, then 2 of them are out of the selection. So out of 12, we have to select how many? We have to select 5 now because brother is already selected. So his space is fixed. Other 5 people are to be selected from the remaining 12. Here, same will go with this. If sister is there but brother is not there, so we can multiply the previous case by 2. Okay? And neither of them, that means both of them are not in committee. So we want from 12, all the 6 people will be from the remaining 12, brother and sister are not part of it. Just add these two and we'll find the number of selections. It comes out to be 2,508 ways. This is a bonus question. It is from Specimen paper of 2020, paper 5. A group of 8 friends travel to the airport in 2 taxis, P and Q. Each taxi can take 4 passengers, and of course the driver will be here. The 8 friends divide themselves into group of 4. One group for taxi P and one group for taxi Q. John and Sarah are traveling in the same taxi. That means both of them are either in taxi P or taxi Q. So let's focus on taxi P first. So the 2 seats have been taken by John and Sarah somewhere. Maybe these 2. We don't know where. So how many are remaining in these? These are just 2 seats left. So remaining people, total 8 people are there. 2 people have taken their seats. So 6 people, we need to select 2 people for these 2 seats. And the second one will be that the 4 people are remaining and all 4 will be selected for taxi Q. But the situation could have been opposite, that John and Sarah sat in taxi Q. So this whole combination, this selection will be doubled because we don't know which taxi they took. And this will give us the number of combinations possible. It comes out to be 30 combinations. Okay, there is another part for this. This was already visible here. Each taxi can take 1 passenger in front and 3 passengers in back, like the diagram is shown. Okay. Mark sits in the taxi P. Okay, let me change the color so that it's clear. He sits in taxi P. Alright, and John and Sarah sit in the back of taxi P next to each other. Okay, this Mark is in front. So Mark comes out to be here in front. Okay, John and Sarah on the back side next to each other. So John and Sarah could be this way, right? Or John and Sarah could be this way or opposite of them. It means there are 4 ways to let Sarah and John sit next to each other. Now there is 1 seat left in this when John and Sarah have taken their places. 1 seat is left in the back. For that we have to select 1 person from the remaining, how many? There are 8 people. John, Sarah and Mark are here, so remaining of 5 people. Out of those 5 people we have to select 1 person for the remaining seat. We could have written 5P1 also, but that doesn't make sense. We are selecting, we are not just selecting because there's just 1 seat. No arrangement required. Now, for the next taxi queue, we have to give 4 seats to 4 people, so the arrangements will be 4p4 or 4 factorial if you want, right? That can be written. And if you multiply all these, it will be 480 arrangements.